Alright, so why I bring this up? Because the interesting thing is that not only is it important for hormones, but also, as you can tell, like, not only do I love endocrinology, I love pharmacology as well. But drug metabolism. So what happens here is like, you can have drugs that, so you can have drugs that aren't the same, exact same chemical structure as a hormone, but can bind to the same receptor or similar receptors and cause similar effects as the actual hormone. But in terms of drugs, these aren't necessarily hormone drugs. I'm just giving examples. So ethanol, that's what we know as like, that's the drinking alcohol, the alcohol that people, or I guess if you're over 21. But this is the one that if you drink, you won't have to go to the, or actually I'm saying, this is the one that's the least toxic. Like methanol will make you go blind, and isopropyl, yeah, you don't want to drink that as well. But this is drinking alcohol. So water solubility, this is why you can have mixers and alcohol. And when can you detect it? Well, it's the, sorry, you can detect it within, I swear I don't have the Rona, but okay, so that are hydrophilic. Now caffeine. So caffeine, what we have is hydrophilic. Caffeine is hydrophilic, of course. If it wasn't hydrophilic, your energy drinks, your tea, your coffee would have this white powder floating around in it. So caffeine is hydrophilic, and when can you detect it? Within a matter of hours. So again, these are all hydrophilic compounds. Codeine, so this is a common drug um, used for was it painkillers? So what happens is that it's also hydrophilic, and when can it be detected? Similar scope with like, it's very interesting. It kind of like has to go under multiple rounds of metabolism, so you can detect it within days. Now, with caffeine, if you drink something at 9 a.m., are you still going to feel it like 3, 4 days later on? No, right? So the thing is interesting about hydrophilic compounds, because they're easily dissolvable in water, you can also easily excrete them and get rid of them from their body. Now, cannabinoids. So ask the chat, where do you expect to find cannabinoids? Yeah, marijuana, right? So marijuana and weed, so this cannabis sativa, right? So cannabinoids are hydrophobic. So cannabinoids are hydrophobic. So remember, it's just like my greasy dish is analogy. So hydrophobic compounds don't have an easy time washing away from your body, right? Because again, why it has to go under multiple metabolism to make it to the point that it can actually be, or it has to be dissolved in other hydrophobic compounds or detergents. So what happens is that this is why cannabinoids they stay in your system longer. And the interesting thing too is that they can also, someone said adipose, so cannabinoids can also be absorbed by fatty tissue as well because it's hydrophobic. So this is very interesting. Hormones that are hydrophobic or drugs that are like hydrophobic hormones, they tend to accumulate in fat and they tend to last longer in the body. Testosterone conjugates, like say someone is under hormone therapy or they're like a dude bro who wants to get really jacked in the gym. So if they're taking testosterone, testosterone is steroid, it's hydrophobic, and it lasts for longer. So why? Because again, things that are hydrophobic, once they're in your body, they have a harder time being, they're not as easily excreted through your urine and water soluble, or they're not water soluble, right? So they have a hard time dissolving in your blood and being excreted through your urine. So this is why hormones that and drugs that are hydrophobic, they tend to have longer lasting effects because again, like that greasy dishes analogy. So this is why it's very important to know hydrophilic, even though it's very basic principle, hydrophobic versus hydrophilic really has a strong effect on whether a hormone or a drug that acts like a hormone has a short-term effect versus long-term effect. Like, can you imagine if the caffeine the triple espresso you had lasted for the entire week? I mean, you wouldn't be able to, it would be more like amphetamines or something if it kept you up for days. So this is why it's also very important, and this is why chemistry is important, because again, you have to kind of know that. Are different body masses affected by these detection times? That's also interesting too, because depending on how much the body fat percentage is, especially for obese patients, it's very interesting. Like, think about it. Like, if someone has a lot of white adipose tissue, and you give them the same dose of a drug as someone who has not as much adipose tissue. How will that affect things? Yeah, that actually sounds like a really good Packback question. I won't answer that. But yeah, that has implications for patients who are obese and have a high body fat percentage. Yeah, so it's very interesting. Yeah, so I've avoided top hat questions for this first week because again, our class is being activated next week, so that it covers everything from January 14th or January 18th to May 18th. So you're covered for the entire 4 months. So yeah. So we will have top hat questions starting next week. I will kind of like give everyone next week to get signed up. But yeah, this is why Top Hat hasn't been fully activated for our class because again, we want to make sure that the 4 months last past that May 14th day of the final. So that everyone's can you imagine the disaster if everyone's subscription like expired on May 11th and then we have our final on the 14th, no one can access the class. Oh god, that would be like yeah. So again, Packback is due this week if you want it. It's like so Packback. There are no mandatory weeks, but you're still up to you to get that 1,500 points by the end of the semester. So no mandatory weeks, no free weeks, no makeup weeks. You can take your own weeks off. You can, but it depends. Like, are you going to get the max 150 per week, or are you going to take a light week and go harder the next week? Either way, it's up to you. You can get Packback done in 10 weeks, or you can distribute among the 16 weeks as however way you want. So there's no mandatory quotas one way or another, but there's a maximum 150 points possible per week. All right, so we're way over time, and again, no lecture on Monday. It's a federal holiday, or is it a federal holiday? I know, like Hawaii change. The state is a little different from others, but yeah. Stream Warzone. Oh, I should. That's one thing. Maybe during the summer or spring break, I should do that. Yeah, MLK Day, Martin Luther King Day. I forgot if it's a federal or if only Hawaii does that. I know there's like some things we do, but we trade one of the days for Discoverers Days. Like we don't do that, or Indigenous Peoples Day. But yeah, it's Martin Luther King Day on Monday, so see you all on Wednesday. Enjoy the long weekend.